So 2 housekeeping things. If you don't have a book in your hand, I need to get a book in your hand. You need to have a book in your hand because we didn't put this awesome book together to not use it. So raise your hand if you don't have a book, and Elizabeth will get you a book. Second housekeeping thing. I come from an ag teaching background, so these seats up here, I'd like you to get a little bit closer because some of the things that I'm going to show you up here, you won't be able to see in the cheap seats in the back, okay? So buy the good real estate, get up here in the $10,000 an acre kind of territory, step forward if you would. I want you to be able to see, okay? My name's Eric Raker. I'm an extension educator in Northwest Ohio in Wauseon, Fulton County. Also a member with my brother and my dad, small farming operation. We're just a little less than 1,000 acres that we get over. One of these plots is on my dad's farm. 2 of them that I'll reference were done in 16 and 17, and they're not in E-fields. As an extension educator, as a lot of these guys do, I try and stay really close to what's happening on the production side, both from a precision perspective as well as a farm management, margin, profitability perspective. So this is really based on... Man. All right, so you're really going to have to come forward because I have to somehow, I teach it in such a fashion that I got to touch the screen, or whether it's with a laser or with my fingers. So there's going to be fingerprints on here by the time this thing's over, John. I'm sorry. So this is based on 8 site years worth of data, generally speaking, using Y-drop as a technology. So that's fair. That's fair. So I really want to zero in on the right time. And so I can draw your attention in this booklet to pages 60 to 63. So if you would, please, if you turn in your booklet in your hymnal, if you will, to page 60 and 61, we're going to zero right in on the right time. Now, before we focus the rest of the session just on right timing or timing opportunities with regard to nitrogen, I want to call your attention to pages 58 and 59, which drill down on nitrogen sources. Garth and Sam just spent some time on manure as a source that we have to evaluate, right? The right rate, I don't know how many rate studies are in here, but Elizabeth aggregated a lot of those, and those went into the new nitrogen response curve that was supported by the commodity associations. So thank you, commodity associations, for supporting the nitrogen rate work that went into this digital ag book, but also went into Dr. Steve Kallman's work in refining that maximum return to nitrogen rate. That is a tool on the rate perspective that you as growers have to understand how to use and get better at using when we have 860 soybeans and 350 corn and rising input costs. Use that thing, okay? And then finally, John's done some great work with right placement or evaluating placement. That's in this book. Let's zero in on pages 60 to 63, and I'll be very specific. I'm really going to cover 60 and 61 because that's my work. That's what I'm most comfortable with. So on pages 60 and 61, thanks, Elizabeth, for the social media tweet yesterday. I don't know who did that, but it was zeroed in on page 60 and 61 in the hymnal, and I really appreciate it. Amen. So when I sat down with a group of 3 growers, my father being one of them, when I sat down with 3 growers, and actually even in the past, prior to that, Matt Eggers, prior to that is not included in this 8 site years. Your site isn't. But we sit down and we said, how will late season N affect corn yield, nitrogen use, and economics? And really it drilled down to these 4 questions. Can the N application window be stretched? Will late N increase my yield? Is corn more efficient with late nitrogen? And as a result, can I reduce the amount of N? Because I maintain, with my farmer hat on and both my farmer and extension educator hat on, is for the folks that are producing this technology, there's got to be either a win in the nitrogen application window stretching, or there's got to be a win in the reduced cost. If I don't win in one of those two places, it's hard for me to fit this into my management scheme in a corn system. So really, I stole this slide from Dr. Bob Nielsen at Purdue, probably from here a while ago, but this is the end use, the commercial end use efficiency spectrum, right? If we're putting on in the fall and in Northwest Ohio, we just don't encourage that practice. That's more of a, north central states, Minnesota, Dakotas, and Wisconsin, those places generally don't encourage that. But as we move, it gets more and more green, more and more efficient. And so we're going to try and drill down. This research is drilling down at kind of this planting, this V4, V5, and also in this V10, V12. If you're out in Nebraska, you can do some fertigating. We have maybe two center pivots in Fulton County, so bad water. So here's the study design. We put on basically 70 pounds at plant, 2 by 2. One of our choices was an early side dress, which is what I would call the check, and then finally a late with drops at V10. And all of our treatments got right at that 70 pounds, plus or minus 10 pounds. Give me a little bit of leeway there, okay? 70 pounds. So generally speaking, these were our designs, 70 plus 140 to get to 210. And I go back, when you do nitrogen work, you really have to start with the end in mind and say, what's my yield goal? What's my yield goal? And generally, I'm probably using Dad's approach to nitrogen management, a 1-to-1 ratio, right? One pound to 1 bushel. Hopefully, I'm not at Grandpa's rate, a 1.2 to 1.4 pounds per bushel, okay? Our hybrids, who's seed people in here, hopefully, your hybrids are a whole lot more efficient. The late end, we skipped that V5 and still ended up at 220. The split, so if we split our budget up across 3 trips across the field, 70, 70, 70, do we have a gain? And then the growers I was working with really said, well, we know our hybrids can go to about 0.8 of a unit of N per bushel. They can be that efficient. We've seen it. We've been tracking it. And so in that second app, if we put a slug of it up front with our planter and our pre-emerge, can I come back with about 100 more pounds, and that's roughly going to be, 170 pounds, or translate real close to 0.9 of a unit. All of them really were at that 200 to 210 bushels per acre. Now, when it comes to options, there's a host of options, right, for late season, in-season application. Me standing up and saying one company's brand or another isn't necessarily an endorsement of that brand or against that brand. Please understand that. But you can go across the spectrum. You can go to high-end Cadillac-type systems, okay, that are, the NutriBoss, the Yield 360. But you can also come up with this farmer design. I'm not sure. This was fabricated somewhere in a shop for less than $100 a row. This was something that Fennigs had come up with. I think they've, I'm not sure if that's on the market anymore. And then this is kind of a different style of drop that Miller was using. Just found those on the internet. But generally speaking, all of our work, we didn't really use the center drop, the center coulters like John did in some of his work. But all of ours were attempting to get, there's one that didn't, attempting to get that nitrogen at the root. So, for those of you who have never seen this, this system go through the field, I think, does it pop up? Yeah, you can kind of see this is the last field we did in 2017. It was ironically, my intern crashed his drone on this flight. This is about V12. That's how tall the corn is going through, and that's not a Hagee unit. That's a case unit, which doesn't have quite as much clearance, but you see the drag on the corn just a little bit, and you can see the pass from the last pass. Anyways, just some cool footage to see to include in kind of the discussion. That's what it is. Now, I maintain that I can be data heavy when I put stuff into e-fields, right? I collect a lot of data points because I think that's important for the guys that are on the edge to understand. You don't you can't evaluate those things you don't measure. We did a pre-side dress nitrogen test. I'm not going to talk about it right now. We did cornstalk nitrate at the end, calibrated yield monitor, calculated nitrogen use efficiency, and calculated economics. I'll talk about what the custom rate is for the average guys, or I can tell you right now so that we're going. I think Barry Ward's survey showed somewhere between 13 and 1375 per acre if you custom hire Y dropping done. That's what our commercial retailers are at. One of the things I think is very important for you to understand agronomically is what I'll call the Purdue Recommendations on cornstalk nitrate tests. How many of you have seen this chart before or have done CSNT's cornstalk nitrate tests? Another great tool that's highlighted in one of the tools of the trade in the eFields booklet. But really, you just take these little billets that are about 8 inches off the ground, you snip them twice, and you get about an 8-inch billet of, is what I call it, of a cornstalk. You send it off to the lab. We got in every strip, we always did about 10 or 12, or that was one of our samples. It comes back, is it low, optimal, or excess? Low, less than 250 parts per million nitrate nitrogen, 250 to 2,000 optimal, and over 2,000 is luxury, is excess use. That's not where we need to be. You're wasting, it's really simple in my opinion, from a cornstalk nitrate perspective. Losing money, even money, losing money. Let's put it in economics, right? So let's talk about the Fayette site. You don't really have the Fayette site in front of you, so wait until I get to the Wauseon site because I have 3 years of data on pages 60 and 61. Let's talk real quick about a site in Fayette that we did in 2016, 2017. Side dress nitrogen source was UAN, and the placement was right in the center of the row. Good picture of it there. So our 2016 yield, no statistical difference. In a check, a late N, a split N. He didn't do reduced N in 2016. In 2017, he did. No statistical difference except at that reduced rate. I mean, our LSD was about 12 bushels. So, I don't know. I'd emphasize. Let me go to the next slide. So the 2-year summary, if I just take simple averages of those treatments, I get 226 bushel check, 227, 231, 220. It's kind of presentation math, so I don't have the statistics here, okay? But I'm gonna scratch that number 4, okay? Because I only had 1 year. Why did I scratch it? I only had 1 year. You should be a little more critical of me. Should I have all the others? Should I be talking about the others with you today? John says yes. I technically I'm so critical of myself that I really shouldn't be talking to you about just 2 years of data. I'm concerned about 2 years of data, but I have 8 site years that I'm talking about, so I'm going to put it in the mix, if you will. So here we go. CSNTs in the Fayette site were luxury, and then the reduced N. So something to pay attention to on the CSNTs. I think there's a teachable moment there. Do we need? We don't need that split N really from an environmental perspective. We're operating pretty good in their standard check procedure, which is an early side dress. I don't have any nitrogen use efficiency gain until the reduced N, and then I look at the economics. Okay. And if you're custom hiring this done, I would argue that I need to subtract out about $27 out of this. $13.50 if I'm custom hiring Y drops to grow a crop. Well, I think Barry Ward lists $13.50 for a side dress application, and he lists maybe a little less than that for 28%. Call it $10. I gotta win about $25 back, and I'm not doing it. Okay, so from an economics perspective, I'm not sure at the Fayette site I gained on the economics. Did I gain on the window? Did I open my window of nitrogen application? Can I go in with some confidence late in the season and still get the same yield and essentially the same economics? And the answer is yes. Okay? You only get 3 questions, Bill. First one. Yes, sir. Except the reduced N. This was about the 170. Yes, sir. Good point.
If you took the 35-36 and cut that rate in half, you'd have ended up with 1368, and saved economic would have showed up there.
I think there's some things to learn down in here, and I'm disappointed this farmer didn't come back for a third year and try it again in 2018, so that we could learn more on this reduced N. So I'm still working at building or refuting a case for reduced N in that late season application. This guy only did it 2 years. I got two more sites to talk about. Okay, I got
Longer years?
one of them's a 3 years. 3 years. Okay, yes, sir. So the last question first. I don't have my field notes into the presentation, but generally speaking, I'm going to address the nitrogen stress based on the CSNTs. That's how I'm going to address it based on what I have in the presentation. Generally, we did not see nitrogen stress until we got this reduced rate. Okay, that's the question to my answer to your last question. The first question. So you're asking me a question with your farmer hat on, and I'm going to respond to you with my researcher hat on. From a research perspective, I wanted, in my preliminary 3 years of research, or 8 site years, I wanted to try and keep that rate as static as I could, that total, so at 200 to 210. So I agree with you. I think on that split end, we could back it down. But I really would like to see the total end too. So I'm adding I'm adding 3 more reps of a Y drop pass in there, and I run out of field space on an 80-acre farm is what it comes down to. So you make a very valid point that we probably, on this split end, instead of putting 70 pounds on there, what would happen if we put 15 gallon on 45 pounds or something a little bit less? And that's, you make a really good point. With my farmer hat on, you do. With my researcher hat, I got to be, first layer of research, I want to be pretty static.
I would consider your high CSNT numbers on your split rate as more residual land that may have gotten used, like at least it was available for that kernel to build.
Yeah.
That would be an indicator to me that I just put too much on that late application. I should have put more on later on. Because that 70 pounds at the starter for hanging out there until E10, that's not a lot of it for the corn planting in the very first stage.
Yeah. I agree. I agree. And we could have been just a tick higher on that. Again, we were trying to, with 3 growers, we were trying to be relatively standardized so that in every research project we can find a hole. And it would be great to tease the rate out on that last, if we could have 3 rates, man, that'd be really teachable moments. I don't have that data in any of my 8 site years. I'll apologize, but I also know that's a slug of work on the field level. Okay? So, and I have 2 more sites to talk about, and they're a little bit different. Okay? So this is at our Delta site, and this is what I would call my purest site it was 28 all the way through at side dress and late, and at side dress I got the placement perfect. Okay, the grower had 360 units that he put on his toolbar, and so it was dribbled at the stalk. So from a placement and a source perspective, I'm standardized. Okay, so if you've never, this is just another little quick video. I'm a fan of videos. Thanks to Ross Andre, OSU grad, acre intern that came and volunteered, well, not volunteered, I paid the guy. My intern who did a lot of drone flying in the summer of 2017. But so these are the Y drop units dribbled at the root. You can tell it's obviously shorter corn. The previous video I showed you, and so that's how it went on at side dress. On his split application, he came back and he had the same units on his 24-row rig, highboy, and so same technology was used. That's why I call the Delta site the purest site, okay? And we can see from a drone footage, looks pretty solid, 45 days, almost 7 weeks after the V10 treatment. You can see a little bit, and I don't have the line snapped, but you can surmise that there's a couple of lighter, passes. This is on a 160-acre field, and we used about 100 acres of it in the test plot. Okay, pretty consistent, 30-foot tile drain field. I don't do any research unless it's tiled. These guys were parallel with the tile lines, but they were also harvesting 48 rows. So they wanted to go down and back. I had a young grower in this trial in Delta, and the first year he really wanted to push it. Or after the first year, he learned some things that he was like, holy cow, 0.8 of a unit. I put on about 170 units, and there was no statistical difference. And again, that's what Mother Nature hands us sometimes. So it's field research, and that's what she handed us. In 2017, he said, I want to drop the bottom out. What can I do with 0.6? So he put on, I think, 125 pounds. 126 is the exact math. 126 total units of N. Okay, and he came and he lost. It was statistically different, but especially when you compare it to his check. I think that in 2017, at least in our county, the corn wanted the nitrogen just a little bit earlier. That's evident in the yield from the check where it was dribbled on the surface at V3 or V4, V5. Still, there's lots to learn here. First, in this neck of the woods, who's upset with 207 bushel of corn? Okay, where I'm only putting on 126 units times 30 cents. Someone help me on the math there. What's my end cost compared to 210 units? So, I'm fried, John. I'm sorry. So let's do the 2-year results. Essentially no difference. I pulled out that 0.6 of a unit because I don't think that's fair to compare. The CSNTs, all on this farm, all right in the sweet spot, 250 to 2,000, right in the optimal range. I will say that both the grower and I, overall, on a 2-year average, were not as impressed with the nitrogen use efficiency. We would like to get that below 1. But then you look at the return to N, and I think this is what, they own their own drops. They're not paying a custom rate for it, but this is what caught their attention. Okay, if I'm going to buy those drops, I got to be able to somehow create a value case for them, either reduce cost or increase the yield. Onward. This is Fulton County. This is my father's. He's an anhydrous warrior. That's all he wants to use because it's rock bottom costs, he's a conventional till guy. This is page 60 and 61 in your book. So if you'd open your hymnal to 60 and 61. So we put it obviously in the center of the row, 15 inches off the corn row at V5. The source was anhydrous. You can kind of see what our treatments were. We detailed out how the placement was in each of those treatments. So there's some moving parts. So researchers, Emerson, you can shoot holes in this if you want, but it's a system. Okay, I'm going to argue that I have an anhydrous at V5 system, a late N as 28% at V12 system, a split N system with anhydrous at V5, okay? We'll come back to that. And so on. There's a pre-plant anhydrous system of nitrogen. So 5 different systems. Sorry, I could have pointed to this. You get it. The total rates, in every one of our growers, I tried to ask them for a reduced rate because I maintain as a researcher and as a farm economist, we got to create the value proposition. All right, so moving on. So you have this little data at the bottom of 61. Let me help guide your eyes. Take out your pen and mark these circles, if you will. Here we go. Number 1, in 2016, is there any statistical difference? No statistical difference in those 3 treatments. In 2017, we added a treatment, reduced. I guess that kind of happened with dads in year 2. Is there any statistical difference? No. 2018, moving forward. Statistical differences last year. Yeah. What do they probably follow? What are the A's maybe associated with? What system? Doggone it, Dad. What system are they associated with? Huh? Ammonia. Okay. So this was clean data, and then, it's fair for you in the audience to say that it could be tied with ammonia. I think that's a fair argument. So I had ammonia in the check, I had ammonia in the split, I had ammonia in the pre-plant. But I got an LSD of 5 bushels. They're all pretty tight. I mean, there's no more than a 8 bushel spread. I mean, this reduced kind of bit us, an 8 bushel bite. Okay? And then I'm gonna highlight, because I love to talk about NUE. If you're not tracking NUE in the Western Lake Erie Basin, how many of you are in the basin? Okay, if you're in the basin, you got to keep track of how many pounds of nitrogen go on every field, right? So it's so easy. Do you keep track of yield for that field? And the answer is absolutely. Is it tough to calculate your NUE in the Western Lake Erie Basin? Not if you're keeping your records like you should. Okay? If you're keeping your records, it's really easy to calculate NUE. I don't like an NUE over 1, but we have had them in 2018 over 1, that block of data. But that's Mother Nature screws up NUE. If we got a normal year, I think we can be living at 0.85, 0.9. I think you need to start tracking that on a field-by-field basis, year over year. And then finally, of course, I love to talk return above, and really just, my dad loves seeing this data. I mean, Dad just loves it. So he's just saying, well, shoot, baby. And of course, Dad waits to get in the field till the corn's like this tall, That's what the old anhydrous guys do, get in way late. So Dad starts scratching his head and says, well, you guys have been talking to me about trying to get in when the corn's this tall. Maybe we can do that now. So baby steps. I mean, we're trying to make inroads where we can. So we're getting in just a little bit earlier. So, anyways, economics. There's a $20 swing in there. Without a real fair calculation on the difference between gas and 28. So there's moving parts in the systems. I could get a little bit more critical on the economics if I really wanted. With Dad's, I feel like we're in the sweet spots again. 2-year NUEs and that hanging around that 1. I really like seeing this. I mean, I think on the 3-year data, this is a 3-year summary. I mean, economically, I can keep up kind of at that reduced rate. I took out the pre-plant because I only had 1 year of that. Okay, that's why we're not talking about it. Yes, sir. Oh, no, how many? Bill, you got 2. You're good. Don't take offense. Yes. Different years.
Results from a late application or a split application. So my question here is, how much do you foresee the need or the importance of monitoring the weather in season, making our decisions in season on when we're going to pull the trigger and what our rates are going to be, and then how do you foresee us being able to
You predict your 30-day weather, and you can hone in. Accurately predict your 10 to 20 to 30-day weather right there. As that, I had that Purdue Site graph on efficiency. If you can match those, perfect weather conditions with with the timing of your nitrogen between that V5 and VT, that's paramount.
Class right there is telling me that that's not going to happen because we can't predict out accurately 30 days.
Yeah. I mean, it's tough, right? It's tough to predict the weather. So, but I think if you have a weather forecasting, weather modeling is getting better. And so I think as those models come online, or you get more familiar with them, I think that's that prediction 20 days and 30 days out is tremendous. If it's going to be a soaker, if it's going to be dry, well, shoot, yeah, we can dial in our rates. But to say that every year, that's a tough thing. So. Please.
You guys are saying the same thing, is though, if you do go back some, let Mother Nature play the cards and help make a decision, because we can't do it 30 days, 40 days, even if it's in that or let Mother Nature make cards out to her perspective. You may not have to use it, I think, the earlier one, right? And that kind of, just kind of summarizing.
No, I agree. The more we know weather on nitrogen, the better situation we're in. So.
The timing, I need to see you do that we found a lot of what we've done the last few years. There's some years where R1, R2 application timing is off the charts. And it's just a little bit of M, and it just has a big response, especially with some of our later work. But Purdue's done some work on that too.
How many gallons? 28, or how much at R2?
It depends on the year, but it went down as low as 30 units of N, up to 45 units of N.
Oh, okay.
So anywhere on urea, flying it on with an airplane, you can get by with 70 pounds, 75 pounds of urea.
Okay.
And then we throw in ammonium sulfate with that too, at 91. And then we've been as high as 100 pounds of urea, ammonium sulfate, and that puts it at that weight this urea, 45. And you can see anywhere from 10 to 20 bushel, depending on the year.
Yep. Good points. Good points. The last, my 8th site that I've worked with was with a precision ag, with an ag leader gentleman and another farmer who's doing some work on optics, on sensors. It's really kind of outside of my comfort zone, but I'll show you the data because I was involved with that grower in Lenawee County, Michigan. He did 70 pounds, 10 gallons, 25 gallons, 40 gallons, 60 gallons, and this was all at about V8, okay, and then came in with Optrix, and his field average on those strips is about 136 pounds. This, if I could get rid of the 70 pounds part, this is pretty impressive from sensors. But when you leave the 70 pounds in there, growers going, well, shoot, why didn't I roll with just 70 pounds, planter applied? I mean, why save my trips? But you can't do that every year, and I think this was you can't do that every year. But this is pretty impressive, and I think I have lots to learn on sensor technology. But what I know on sensor technology is it's here to stay, right? I mean, it's not going away. So something to take into consideration. Look at these NUEs. This is my love language right here, man. This is the NUEs where I'm pointing at the wrong spot, but I'm under a 1 on all those. And again, I'm going back from an economics perspective and saying maybe those soils are more organic, maybe I didn't need as much. So let me summarize. The questions that we started with, I didn't get the animation to work on this. My first question was, with these 3 grower groups in this little cohort, can the N application window be stretched? Yes. 86, actually it should be 87.5% of the time, because we had only 1 out of 8 years where we didn't find that it could be stretched. So generally speaking, can we stretch that window without sacrificing yield? Yes. I think you need to study the equipment just a little bit. Okay? That none of these were dribbling 28% on in the center or in between the 2 corn rows. So be aware. Number 2, will late season N increase my yield? On 8 site years, The additional laid in never statistically increased my yield. I think that's an important note to take away from 8 site years in Fulton County. Number 3, is corn more efficient with laid in? Yes, we saw that especially with this last. Our NUEs are really quite efficient, and a corn specialist might throw darts at it, but generally the later we get down there, we're getting very efficient the later we go in the season. Can I drop my N rate and therefore reduce my cost? This didn't include the Michigan trial. Actually, 4 out of 6. When I include the Michigan trial, 4 out of 6 times the reduced rate treatment did not sacrifice yield. So I'm not going to say positively yes or positively no. I think my best answer is it depends. I have seen 4 out of 6 times in the growers that had a reduced rate treatment, that 4 of the 6 did not sacrifice yield. I think that's an important take home. And lastly, are there other environmental and economics considerations with nitrogen? Of course, and always. Okay, there's always other moving parts, especially when you're doing field scale research. Any thought? Any questions, darts, comments, holes? Yes, sir. That was at V8. It was a little bit different. On my 3 trials in Fulton County, we were really shooting for V4 on the side dress, V4, V5, and then about V10, V12. I mean, took a high clearance sprayer to get through. But on the Michigan trial, the Optrix trial, that was kind of at the direction of another CCA, V8. So V8, whatever, V8. Good question. Other thoughts? Yes, sir. That's a great question. The answer is no. I think there's 2 treatments that I can make a real good case for. The treatment that I'd make a case for beyond that one, or in front of that one, is a 0 rate altogether. But talk to a farmer about turning his starter off with his planter, and that's a tough, across a field length, that's a tough proposition. So unless I got John's money, then I can pay him for it. But the other treatment, where he had 0 up front and everything 210 units later, no, we didn't do that one. But it would be interesting, right? Be interesting, or probably if I put the full rate on, someone in the room would say, well, why didn't you put the reduced rate on at the same time? Of course, now I'm at a 320 acre field that I got to get across, or a small test plot. Yeah. So in Fulton County, I've had about 16 nitrogen rate trials in my time with Extension. And that curve from a maximum return kind of tips out between the 150 and the 200 rate. I would call it right in that. I would say it's closer to 180. I mean, I feel like it fits the economic optimum rate that's housed on the Iowa State website pretty well. But yeah, we published a lot of work that said you don't need to be at 200.
But, with the environmental pressures.
Yeah.
I think we need to be looking at those lower rates.
Absolutely.
than the higher rates.
Absolutely. We need to be testing those limits. It helps with nitrogen prices going up and corn price staying stagnant. I mean, if you're not doing your math, you're crazy. I mean, all of you growers in here, how many of you know your cost of production? Okay? And of course, I'm probably talking to the choir here, but I get pretty wound up about you knowing your cost of production. I mean, no other businessman in the world, rolls out this much capital and doesn't know their cost of production. Okay? So know it. Yes, sir.
We've been doing this for 5 years, I think, but we don't work in fields like this. We're in the east and have extreme variability in soil types, and also our focus has been a lot on just reallocation of it within the field.
Scripts.
So we've used green seeder technology and
Right. If you do field scale nitrogen research, and you'll see this in the observations on page 61, you made a great point that if you're doing nitrogen research, whether it's subsurface applied or surface applied with a drop, you really need to know, you need to write down if you got rain after that or not, and how big a rainfall event you had, and how many hours after you applied 28% or urea, if it's urea. Generally in our neck of the woods, it's either gas or 28%. Yeah. So I think some of that, I think some of the discussion with the Y drops, is, those guys still operate under this premise that if they're going to get, we're watching the forecast for a little rain. We want a nice little rain. So, I mean, that's a certain weather risk, right? I want a 1/4 inch. I want 2/10 after I put Y drops on. I'm going to go over 700 acres. Well, what kind of risk are you taking there? You're taking, nitrogen's risky business. So, if you look at page 58 and 59 on the source work I'm doing with John Deere in Fulton County, and Les Seiler, how many of you know Les Seiler? Les Seiler's an avid no-tiller. So, the stuff we're doing up there in the Western Lake Erie, we're in the basin, and so it's kind of the opposite of this. You can throw darts at this because I'm putting nitrogen on the top of the soil. But on Les's trial, we're using urea, ESN, anhydrous, and 28%. But it's all subsurface applied, even the urea and even the ESN with that 2510H toolbar. And so, it's dare I say that's probably the direction we need to be, more than lots and lots and lots of acres surface applied. Sorry, I'm not supposed to give so much opinion. I give too much opinion. It's bad. Some people. Yeah, go ahead, Matt. So the site in Michigan had manure. So that I didn't disclose in here. That's a great question, because this system, this late system, and cornstalk nitrate tests or the what's 360 call it? Who's a 360 guy in here? Soil? Is it soil scan? Soil scan? That system is really for guy with high organic N. So manure guys. So I'm thinking back to my sites. No, the Fayette site was lots of years ago, pig manure, and I would say Dad's was. So yeah, there's some moving parts there too. It's great. It's a good group of farmers. Throw darts, man. It's good. It's good. Yes, sir. That would be great research. None of all these are without a stabilizer inhibitor. So great question. That's work that needs to be done. For my part in it, and as a CCA, I would maybe argue that late in the season, at even V5, I'm probably not making a good case for an inhibitor or a stabilizer. But that's not to say work couldn't be done on it. Good question. Yes, sir. I did not. Only CSNTs. So I feel like that PSNT, that 12-inch deep sample, is probably best before we go into side dress. The CSNT, I feel like, is kind of what's left in the gas tank kind of test. Yeah. Yeah. No, we didn't. We didn't, and it's probably because of my preference towards that CSNT at the end of the season.